Hi, this is a follow-up video to the basic parabola video that I have made, and I want to tie it in with work that we did when we were dealing with the algebra component of quadratics, and that was the process of completing the square. Now, the equation that we've just been working with was this one: y is equal to x squared minus 2x minus 3. Now, I'm going to complete the square on this, and I'm just going to work on the right-hand side. I'm going to start off and I'm going to look at those two terms, the first two terms, and I'm wanting to use those as the basis of the perfect square that I want to create. Now, if you remember, when we were dealing with this in the algebra section, we said to complete the square, you look at the coefficient of your x term, halve it, and then square it. So half of 2 is 1, and I'm going to square it, and I'm going to add that on. Now, if I add it on, I'm going to change the value of the right-hand side, so I'm going to straight away take it away, and then I'm going to leave the minus 3 that was there already. So this part over here, I'll just do it in a slightly different color. This part over here is really adding 1 squared, taking away 1 squared. So I'm not changing the value of the expression at all. Now, if I go and tidy this up on the right-hand side, I can now factorize those first 3 terms into this, x minus 1 all squared. And then I've got left over, I've got minus 1 squared, so that's going to be minus 1, minus 3, that's going to give me minus 4. And so I've now completed the square on the right-hand side of this expression, and we've got this equation. Now, if we go and drop in that picture that we had before of the parabola, there's the diagram of that graph. This is the diagram of the graph y is equal to x squared minus 2x minus 3. Now notice down over here, the turning point that we have is the point 1 minus 4. Now, we also said that we had a line of symmetry that ran down the middle of this graph over here, going through there like that. Now, if we look at the completed square format, we can see that we can actually pick up the coordinates of that turning point by looking at the equation when it's in its completed square form. Because the value 1 is the value that I can put into this equation to make it equal to 0. Minus 4 is the component that I had at the end over here. And this basically shows the transformation of the original parabola y equals x squared, which would have come through something like this, and how it's been transformed. It's being shifted 1 place over and 4 places down. And so the completed square format over here gives the instructions for that transformation, the shift that you have to do. It gives you the turning point of the graph. So if I were to give you an equation like this, y is equal to x minus 2, or let's make it x plus 2 all squared plus 3, then straight away we can say the turning point is going to be given by these two coordinates. The value that will make this bracket over here 0 would be minus 2. And then I've got the other component, the number at the end over here, that's plus 3. There is my turning point. Now this is very useful for parabolas that don't cross the x-axis. So this particular parabola that we have here, I'd go 2 places over to the left-hand side, minus 2, and I'd go up 3 places, 1, 2, 3. And so there is the turning point, and my graph is going to be going like that. I don't have any x cuts, so it'd be very difficult to be able to draw the graph if I didn't know where the turning point was. So this is a very useful application of completing the square. Hope that helps. Goodbye.